Okay, so we'll talk about Newton's method, which is simply a method of using linear approximation to find the zeros, or the roots. Just go back to that. Yep. Find the zeros, or the roots of an equation. And it's just a series of iterations that we use to go ahead and do that. So let's work through this really quick. So we start with our linear approximation equation, but we'll use y instead of L of x. And we have our function f of x, and 0 is our initial guess at the zero. And that's times the derivative of the function, and then times the difference between x and the 0, or the x, our first guess. Okay? So since we're trying to find the 0, that means the whole equation is equal to 0, so y is 0, right? We're talking about the x-intercept on the axis. And so we now have f of x sub 0 plus the derivative, x sub 0 times the difference. And if we solve that for our x, or let me differentiate it with a 1, so we'll say x1. So my new x sub 1 is my x sub 0 minus the function value over the derivative value. Okay? And then if we were to do the next step in that, once we find x sub 1, we're going to use that, plug it back into the equation for x sub 0, and find a new x value. And we keep doing that. Oh, that's a sub 1 there. Sorry. X sub 1. And that's x sub 1. And we keep doing that until we find the closest approximation to 0. So as we get smaller and smaller numbers, and then if we start to get further away, then we know that we've reached our limit. And it goes fairly quickly. It is pretty efficient. It sounds tedious, but it's not too onerous. All right, so the general formula for this, and you can find this on page 217, is x times the n plus 1 is x sub n minus the function value at x sub n divided by the derivative value at x sub n. Okay, so let's look at one example of how this might work. And let's take the equation where y is equal to the cubed root of 7. Okay, and specifically I want to find out where that might cross the x-axis, okay, or what is the root of that. So I can put this into more of a general form. We can cube both sides, and so that would be then that, or actually it's not x is equal to that. So then I get x cubed equals 7. Okay, and so we'll say that's our function then. So our function is where this is equal to 0 of x cubed minus 7, just subtracting 7 from both sides. Okay, and if I were to graph this, that's approximately what it's going to look like. And it looks like I'm going to have a 0 at around x equals 2. Not quite. Okay, and I want to find that. So I'm going to use Newton's method to figure that out. So I'm going to use 2, since it looked like it was close to 2, is my x sub 0. And then just plugging into the equation, I get that x sub 1 is going to be x sub 0 minus my function value at x sub 0 over my derivative value at x sub 0. Well, my function value at x sub 0 is going to be -7. Whoops. Or actually, so it's going to be 2. No, it's not. So it's going to be some x sub 0 is that. So that is going to be 8, actually. And my derivative of this, so the derivative of f of x is 2x squared, or 3x squared. Okay, and so my derivative value at 2 is going to be 3 times 2 squared, or 12, right? So that'd be 4, yep, 12. So x sub 1 is going to be 2 minus, well, f of x is x cubed minus 7, or 8 minus 7. All over 12. And doing the math, that is 2 minus 1/12, or 23/12, or approximately 1.96, well, oops, 916. 7 repeating, or 6 repeating. Okay, so that's my x sub 1. If I can do this again for x sub 2, okay, I now go ahead and I put in 1.916 and repeat, minus whatever the function value of x sub 1 is, find the derivative value of x sub 1, and I'm just not going to do the math here. You can do it if you want, but this is all going to go out to approximately 1.912938, and continues. And we can go ahead and do that. And if we did that, keep going. If we did that for x sub 3, we would get 1.91293, and 1, and that's going to also be the value about for x sub 4. So since they're about the same there, that means that's my value that I am interested in. Okay, so, and if we're going to go ahead and figure out what the cubed root of 7 is, it would be 1.9129311. Okay, so that's Newton's method. It's just a method of trying to figure out where the zero or the root of an equation is, and we can do some of those problems in class.